So the defense rests. I think I should just quit while I'm ahead. Thank you, Sanjay, for the exceptionally kind introduction. Um, I think the short version would have been I do what Lissa does except with computers instead of kids, or I do what Alan does but with language instead of vision, and I think that's the whole story. I like to build things because I'm a computer scientist. The thing that we're trying to build here is work in progress, being kindly funded by the Science of Learning Institute, which is why I'm talking about it here, and it's joint work with these fine people here. It's a little more practical than I usually do because it's about educational technology. So the main point of this talk, I'm sure you all know the joke about the guy who's getting ready to run away from the tiger who's stalking him, and his friend says, "Why are you even bothering? You know, we can't outrun a tiger." And he says, "Well, I don't have to. I just have to outrun you." In artificial intelligence doesn't have to get solved in order to be useful in education. It just has to know more about the subject than the student does. That's how it has something to teach. There's another piece to this, though, which is that it also has to know how to teach. So it's not enough to know the subject matter better. It has to know what it can do that will be a helpful stimulus to the student. And that means having some kind of learning model. Now, that's not too tall an order these days because in machine learning, we know a lot about what idealized learning models would look like. Models that are trying to extract maximal benefit from data. And in some cases, humans seem to be getting an awful lot of benefit from the data. Humans are not perfect at learning, but we might be able to take machine learning algorithms as a kind of inspiration for what human learning would look like, and we might be able to use that to build better educational technology. So that's the main point of the talk. I just want to make it clear I'm not intending to replace teachers, but rather to complement them by doing things that would be too labor intensive for teachers to do themselves. Okay, so the way that models of learners are used nowadays in education are mainly trying to understand what the student currently knows. A model of the student's current competence. And probably the most famous and successful version of this is item response theory, which is trying to test a student to give them an SAT score, or figure out where they should get into college, or whether they should move on to the next course, or what grade they should get. Maybe a more interesting version is formative assessment, where you maybe have a bank of problems that you could give to the learner, to the student, and you want to decide what to give them next based on the easiest thing that you think they don't know yet. So you're always trying to get feedback from how they've done on the past problems. And this could be used for interactive homework, so think about things like Khan Academy, which often does a great job of interaction. Intelligent tutoring systems, which a lot of people tried to build in AI in the 80s and 90s to try to have a dialogue with a student about electromagnetism or something. Quite hard to get right. And more recently, educational games. So everybody wants to gamify things nowadays. And figuring out what math problem the kid is supposed to shoot down next is a reasonable application of trying to model the student. So I want to propose something a little bit different today, which is not selecting educational stimuli from an item bank, but rather to construct new educational materials. So this is individualized in that we'd like to be able to give the student something that she is actually interested in seeing now, as well as something that will be helpful to her now. And in order to predict what effect one stimulus versus another will have on that student, we need to have some competence model and some learning model. So we want to construct stimuli that are predicted to have a desired effect. They might not have that effect, so we still want to assess what they know. And if the actual effect doesn't match the predicted effect, then we've learned that this student maybe learn certain kinds of things more slowly or in a different way, and that will help us provide more useful stimuli to them in future. So the one nice setting for educational technology is immersion. And driving school is the famous example of this, where they just stick you in a car and say, drive. And The secret to this is that there's some kind of what pedagogues call scaffolding. So they give you enough support to succeed in the form of another steering wheel. So at first you might not be doing very much of the driving. You might be focusing on using the foot pedals and getting used to the view out the windshield. But as you start to gain ability with the steering wheel, then your teacher will let up his or her grip on the steering wheel and allow you to do more of the driving, but will still spot you a swerve when you are headed for the ditch. The immersion task that we've been working on is foreign language comprehension. So the idea is if you want to learn to read French, then just start reading French. But we're going to need to provide some scaffolding. Seems like immersion might be a good way to learn a language because kids learn language through immersion when they're learning their native language. And eventually, so do second language learners. So after a while, second language learners get most of their vocabulary just by reading and picking stuff up. And that's a good way to learn because there's a reason that you're reading this stuff. You're reading the stuff that you're interested in. You're learning the words that are necessary for you to learn that subject. You don't just learn the dictionary definitions of words. You're picking up the actual usage, the nuances of how it's used in context. At least for the words that are important to the topic, there's evidence that because you're engaging with them, you're thinking about what the document is saying, that you retain those words better. And finally, I think this is maybe speculation, but I think reading strategies are something that are transferable. So if you care about lifelong learning and learning more than just the vocabulary you were supposed to learn for French 3, then if you start learning how to get by in a difficult situation where you don't know all the words, then that's going to be useful when you want to move into new domains, travel abroad, or learn your third language. The problem is that this might not be possible for adult beginners. So there's studies that show that you need to know, depending on the situation, 90 to 98% of the context words as sight words in order to acquire new words. And that means that to read adult level text, you already need to know quite a large vocabulary. And 5,000 words may not sound like that many, but if you look at the words that are 5,000 down, they don't seem like such common words. Like I wouldn't know those words in French despite having taken several years of it in high school. In addition to knowing these words, you have to know how those words get inflected, like the endings that you put on the words, what order those words get put in, or you won't understand the context that you need in order to get this word. And if you don't understand the context, in other words, you can't answer reading comprehension questions, then you are also less likely to learn and retain the meanings of those words. So all this stuff has been well studied. Of course, one solution is that you could try to immerse your college freshmen in C-Spot, Run, and Dick and Jane. And maybe this would work, although, as Lissa said, kids and college freshmen might learn differently. But you wouldn't be taking advantage of everything that the college freshman already knows about the world, which you would hope to be able to exploit. And more to the point, nobody would actually take the course. This, I think, is also a tragedy of adult literacy teaching, is that you have to give people stuff that they couldn't possibly be interested in if they're trying to learn to read as an adult. Back when I was studying high school French, I found it, although I was a kind of eager beaver student, I did find it to be a depressing experience because we got these occasional exciting tidbits of grammar. And I'm like, oh, now that I know this, I can make infinitely many more sentences than before. That's great. I learned how to do something new. Those were few and far between. Most of what we did was we learned vocabulary. And we had relatively little ability to converse or to read real stuff like the newspaper or a novel. We got assigned like one novel a year, and it would take 6 months to read because you wouldn't really be reading. You'd be looking up every word in the dictionary. Every word in Madame Bovary is about some kind of furniture, if I remember. So I had this idea when I was walking home from school. Maybe we could learn by immersion if you provided enough scaffolding. So maybe I could write a novel. It would be a bad novel, but it would do the job. It would start out being in English, but in kind of funny word order. Like the adjectives would be after the nouns. And then sometimes the adjectives would the adjectives would be in French, but only when it was kind of clear from context what they must mean. Maybe that same adjective had showed up in English earlier on the page, or maybe it's just obvious from context. Okay, well, so I was, unbeknownst to me, there was a name for this kind of deliberate mashup of languages. It's called macaroni, or Macaronic language. Here's a famous poem. What is it that roareth thus? Can it be a motor bus? Yes, the smell and hideous hum indicat motorem bum. And it goes through declining motor bus in Latin in a mashup that would be understood by any British public school student of the 19th century, apparently. So I was imagining writing this novel by hand, but we don't have to do that anymore because the computers got better. So now we have things like Google Translate. And Google Translate can translate from French to English for us. And so maybe we could get it to halfway translate from French to English and produce macaronic text for us. In fact, macaronic text that would be appropriate for the particular reader. Okay, so here is a little picture of, it should be in here somewhere. No, did we close that? Let's reopen that. Okay, so here we have some French text and some English text. And you can see it morph from one to the other. And so you can get anything in between. So if you're at this end here, maybe from context you could figure out what for means in German. If you're not sure, you could hover under it. The English is underneath. And if you want to know how to say, let's see. If you want to know how to say seen in German, just because you're curious, you could hover above. So you can gradually morph from one to the other. That's dropping down, that's sliding up. Okay. So the point is that there's this whole range of stuff that you could show the learner. We've got a whole space of stimuli, exponentially large space, and we could pick anything in that space. So this is kind of meeting the student where they are. We're trying to give them a meaningful reading experience because they can choose what they want to read, and we just decide how much to translate it into English for them. This business of being able to ask for hints by hovering might be a good thing because it's a teaching moment. Here's a word that we put in German for them because we thought they would be able to understand it. So hopefully they can almost understand it, and when they're hovering over it, they're just confirming it or choosing between a few possibilities. So that's a timely hint. And also this is orthogonal to these other points, but the fact that we're able to sort of light things up and give people this gradual translation, I think is helpful in revealing the structure of the language and how words reorder and which words translate as a phrase and things like that. So to just give you a slightly more recent version of this here, which also shows some reordering. Okay, so so here we have states united, but you see there's an arrow there, so we could reorder those, right? Electoral fraud, same thing. So how do we actually produce these translations? Well, first we get a full translation. So we take the text in the language that they're trying to learn to guarantee that it's going to be good natural text. And then either we automatically translate it. So my colleague on the project, Philip Kuhn, is one of the world experts in machine translation. That's one way to do it. So that might give you a bad translation, but it will come with this alignment because we know how the words of French were translated and reordered into English. The alternative is we could take a German sentence, a French sentence that's already been translated into English and automatically line it up, which is something that machine translation systems actually do when they are trying to learn from parallel text that's already been translated. Okay, so given this, you might notice that to go from un tel to such a, we had to do three things. We had to translate un, we had to translate tel, and we had to reorder them. Okay. So that means that we have this space of intermediate states. You could of those three things, you could do any or all, and so that gives you 2 cubed or 8 possible mashups, going from pure French at the top to pure English at the bottom. And you can see here different paths depending on what you click on to get from the top to the bottom. So here it made 1 change, 2 changes, and 3 changes. So internally, something like that is what's going on, and that allows us to get things as different as l'Arizona was le first to présenter à telle exigence, versus Arizona was le premier to submit such une requirement. And it's kind of fun, you know, I would have had much more fun in my French class. I don't know if it would have been pedagogically wise or not, if we had gotten to just spend our day talking about politics, dropping in English words whenever we needed to, as long as we were fluent. And I will say that in first grade now, kids are encouraged to spell the words any old way they like, so that they can write fluently. This is called inventive spelling. And the idea is if they are happy writers and readers, then the spelling will eventually come. Okay, so there's a number of reasons that this stuff is kind of tricky in practice. So rather than read you this list, I'll show you a little animation of the next version of the interface. So nous aurons besoin de gâteaux means we will need the cakes. And there's a number of interesting things going on in this perfectly ordinary sentence. So if we hover over this word, it lights up in green, and we see the red translation. If we clicked, the red would slide up and replace the green. That word is easy, but let's hover over the next word, auront. Now we see it actually decomposes into a stem word and a suffix attached to it. This is an irregular verb. This is the future tense of to have. And so when you're hovering over it, it decomposes into pieces. Then you can move the mouse over just this part, and you see that means have. And if you click on that, now you get this macaronic word, haveront. Now there's more going on here, because this word have is actually part of or avoir is actually part of a phrase. So if you were to move the mouse off it and then come back again, you would now see that avoir besoin de is have need of. And so that all slides up. And if you move again, then you would get a more idiomatic translation, just need. So now we have nous niderons les gâteaux, which is pretty good. If we want to know what that suffix means, that's actually future, but when we want to translate that, we end up getting nous will need les gâteaux. Some other stuff you could do. So this word the is actually in the plural, so we're showing that it matches with the plural suffix of gâteau, just as before we showed that this future marker agreed with the subject of the sentence. And if we want to know where that plural is, we could split it off here, and now we're getting more macaronic words. And if you didn't even know the word for gâteau, you could get nous will need les cakes. Okay, so there's 2 kinds of machine learning. One is trying to replicate human intelligence, and that's traditional AI. The other, which is getting a lot of press now, is augmenting human intelligence to do things like read every hospital record on the planet and draw conclusions from it. It's something people, or do computational biology, which is not a capacity of the ordinary mind. That's not what I'm talking about today. I'm talking about building a model of human intelligence. So the old way of doing this, back in the 1980s and before, was to build an adult. And that's you write down everything an adult knows. The more recent way is you build a learner. That's why AI works now. You don't try to write down everything an adult would know. You build something that can learn when it's exposed to either correct examples, which it tries to mimic, or just given some kind of reward as an operant conditioning, so that it can learn to plan how to get those good rewards. And again, the big point here is that these cognitive models of learners might also have a use in teaching. So what could we do? We can calibrate to find out what the learner knows now. We can construct new materials, and we can decide which of those materials would be good. So in this picture, there's actually 2 learners. There's the student, but there's the system trying to learn how to teach the student. And the system needs to ask, what would happen if the student read a given macaronic sentence? Would they understand it? How would that understanding affect their current knowledge, which would help them understand future sentences? And then what should we do? Should we show them this macaronic sentence or something else. So here is just at a really high level how things work. There's some plan, like to show this particular page of macaronic text, and we need to guess what it is that would do to the student. So the student tries to understand it, and that goes and affects their learning, which goes back and changes their current competence. So now they look at the next sentence, that affects their learning, so forth. So that's the plan, is the sequence of sentences. We might try many plans like this to see what the model thinks is best, and then we give what we think is the best plan to the student. So far, this is just planning a curriculum that you could put in a textbook, because this is not taking this particular student into account. This is an idealized student, the perfect learner, Dora the Explorer. That model may not match real students. In fact, the real students don't match one another. So what we really want is now to do personalized learning. We've got lots of interaction that this student is providing us. So the student interacts back with the user interface through clicking and waiting and getting things right or wrong. We can use that to calibrate our model of how the student learns and what the student knows. And that actually opens up the possibility that the planner might show the student some things just to find out more about the learner, not in order to help the learner right now, but to learn things, to learn how to teach the learner better, how to teach the student better. So the model, sort of the obvious model here of the student's competence is that the student is a kind of machine translation system. Translating macaronic German to English, that should say translating German to macaronic English is a simplification of translating from German to English. So the machine needs to use context to do it. Here's a simple case. So I'll give you a little quiz here. What do you think this word Lohn means in German? If you don't answer if you speak German. Salary. Yeah, that's pretty good. Okay. So it means wages, I think, rather than salaries, but very close. So we've done this kind of experiment on Mechanical Turk. People do come up with salaries more often because they're going by context. Some people come up with loan or loans, and you have to have a pretty good understanding of what the sentence means, better than our model will, to see that doesn't probably make sense. But it sounds like that. How about this one? Years, yeah. So here you're probably using the pronunciation, especially if you know that J might be pronounced as Y. So this is Yara. And you know it's probably plural because of the number 30. So you're making use here of the context of the word, the spelling of the word, and any previous exposure you might have had to that word or similar words or other forms of the same word. So the model of the learner is that they're doing some kind of combination of perceptual cues, maybe by something as simple as naive Bayes rather than a machine translation system. They're asking what English words would fit in the same context as this German word. What English word, have I seen this German word before, and what were the possible things I thought it meant? And have I, at the subword level, have I seen any of the parts of this word before, maybe even sounds, and how do those relate to English words? And so you could build a model of a learner that kind of hacks its way through figuring out bit by bit what the sentence means. Now, we also need a model of how the student learns. So if you think about a standard MT system, it's going to get data like this, where you have a black sentence and a blue translation going with it. The training data for our macaronic learner is a model of what the student is seeing. So they're going to see a macaronic sentence. And the natural way to learn from something like this, there are a few related methods, but this one is called self-training. As you say, you use your competence model to guess what those words probably mean. And if you're sure enough of your guesses, then you update your vocabulary and the other features of your model to say, okay, now I know that Yara might mean years. So real learners, if we want to personalize, might diverge from this idealized model and from one another because maybe learning doesn't always succeed. It takes many exposures. So when you update the parameters of the learner, sometimes those updates might fail, or they might just be too small to make a difference. And sometimes you might forget. Sometimes parameters might go revert back to where they started, toward where they started. And so you want to model per learner, per student, where these things tend to happen. So some students might adjust some parameters fast, other learners might adjust the, other parameters fast or slow. We want to, some learners might be more cautious and they might really have to understand a sentence well before they're willing to make any conjectures based on that. And so for those learners, for those students, we would like to learn to show them sentences that we're really sure they're going to understand well and where there's only one questionable word in it. So as I said, we've done some mechanical Turk experiments, including one that I probably don't have time to show you, where they're asked to use our interface to, we give them a German sentence and we see what they click on to get hints before they try to translate it. And that tells us which words they think they already understand in context, which words are helpful in making them think they understood other words, and then whether they did in fact understand the words that they didn't ask for hints on. So this is allowing us to start looking at the differences between learners and start building what can be an initial competence model that will then try to, these are completely inexperienced German speakers. So this is an initial model that we could start learning from. So there are a few possible ways to extend this kind of system. We don't just have to show them Macerotic text. We could give them quizzes from time to time, both so the system learns something and to give the student an incentive to remember the word to be able to generate it and not just comprehend it. We might ask them to write as well as to read. And then make suggestions to them and say, you know, you probably could have used the word Yara there because you've seen it before. Or maybe you should have put the words in this other order because you kind of know how to do that. So just gentle hints to make it edge toward the new language. And finally, other people have worked on speaking and listening and dealing with accents, and maybe that kind of stuff could be made to work with reading, with speaking and listening to Macerotic text, although getting the junctures between the boundaries between English portions and French portions to come out nicely in speech synthesis and so forth would be an entertaining challenge. I'll stop there. This is the slide I began with, and let me again just thank my colleagues who are respectively a machine translation expert, an educational technology expert, an NSF fellow, and a former employee of Rosetta Stone. Thanks very much.
Hi, thanks so much for that talk. I'm curious about using Macerotic approaches, not to teach an entirely new language, but to teach, for example, the acquisition of academic speak. So, for example, we at the Ed School are engaged in an experiment of whether we can bring current K-12 educators to doctoral status over the course of 3 years. They come in with a specific statement of the problem they want to work on, and over the course of 3 years refine their language about their problem until it reflects dissertation ready, able to work on problems. And it strikes me that 3 years is a very short time span for them to learn how to articulate their problems in terms of academic language. And I was wondering what you might think of this less rule-bound transition from going from regular layman's language to academic language, if it might be compatible with a Macerotic approach.
So that's a really interesting question. You could think about this as a kind of machine translation, a human translation problem, and give them exercises in translating from one to another. So, you know, people go to translator school who are already bilingual, and, you know, they have to do exercises, if I understand correctly. And that would be sort of a more focused way of learning academic speech than just writing about their own problem. the question that you're asking really touches more on the second bullet point here, where we would be asking for macaronic writing and making suggestions to them. And in a way, I'm guessing that that's what you're already doing when they hand in an essay and you're marking it up by hand. And so this ties in with a line of work on teaching fluent speakers, fluent non-native speakers of English to fix their remaining errors. So there are systems that try to teach, say, native Chinese speakers to remember how to use articles in English. So sort of, if you think about the Microsoft Word grammar checker and so forth, you could imagine using those kinds of technologies to flag problems in people's writing, where the problem is not a problem of grammaticality now, but essentially a problem of dialect or a problem of manners. If you think it's bad manners to speak, lay speak in academic text, which is open to debate.
I'm wondering, with this type of adaptive and individualized and personalized learning, to what extent do you believe that you need to depict for the student a visualized progress of their learning? In other words, in this particular case, you may help them learn another language. When they come back to the computer, it will remember its model and it will continue from that point. But the student might not necessarily have any sense of what progress they're making. So I'm wondering how you're thinking that through.
So this is a really important point. Almost everybody now who has pedagogical software has all kinds of rewards built into the software. People are super happy, when their like counter goes up on Facebook, or just getting this constant affirmation, low-level affirmation, seems really helpful to people. So it's done in the Duolingo, for example, which is a free language learning website done by machine learning people. It's focusing on things like learning vocabulary, and it's always pushing you on to the next level and giving you points and so forth. So in this case, the system has to have some kind of metric, I glossed over this, in order to figure out how, whether it prefers this plan to that plan. And a reasonable metric is how German is the stuff that you are now able to read, and showing that to you is a great thing. Also rewarding you for taking more risks, or whatever it is that the system thinks would help you learn faster that's wide open territory. This becomes a general reinforcement learning problem, where the teaching system is what's called the agent, and the student is now the environment. And the agent is just trying to get its own rewards, which is actual learning in the student. But it can do that by telling finding out what makes that student learn fastest. So in a sense, you can sort of do trial and error and figure out what works with what student. So the theory of reinforcement learning is a few decades old, and it's getting better all the time. They are still the hardest problems in machine learning in many ways to actually get to work in practice. But in principle, the system could just try out and find out what kinds of rewards work well for this student.
Let's take one last question. Is there one, or that's it? Repeat the question.
Yeah.
Yeah, this just seems like a really brilliant way to do adaptive scaffolding that could be applied to any sort of problem solving from start state to end state. And I'm just wondering, has this been applied to math or science problems, or what other things are you aware of that exist?
So there's a huge literature, and this isn't really my area. I don't know. I don't know everything that might be relevant. I can tell you one thing I've thought about myself is literacy in the sense of phonics. So there's the same issue of context clues and trying to figure out what somebody... The green light's going on and off here. Is this working? Oh, okay. So there's the same notion of a model of the learner, and for example, what letters they know how to pronounce, what groups of letters they know how to pronounce, what words they know how to pronounce, so that they can make intelligent guesses. And then the question is, if you were to automatically write some fun nonsense story, which you can if they're young enough, then what words should you throw in there in order to give them kind of graded learning. You can do the same thing with typing, actually. You want to give them most frequent letters first that are going to be most useful to them.
Since we are already cutting into our break time, let's stop here and give Jason a big hand. Thank you.